Localized dry spot is a common problem on greens. The cause can be biological as a result of fairy ring attack or colonization of the soil by microbes that produce hydrophobic chemicals that coat the soil particles. A common problem is even irrigation distribution resulting in dry areas. But in some cases, the depth of the root zone might not be uniform. In this video, we illustrate a localized dry spot problem that is caused by non-uniform depth of the root zone sand. So let's take a look at a situation that we encountered just recently with a green that had some undulations that resulted in some dry spots. If a green is constructed properly, it will have a matching. This is exaggerated a bit for sure, but if you had an undulation in a green, the root zone should be the same depth over that whole surface. So the contour of the cavity that the green was prepared for should be matching the contour of the surface of the green. In a situation where you have a green that has a contour to it, and this construction process was erroneous or in error, and they just made the cavity flat all the way along, you'll get some variation in the depth of the soil, and the depth difference in these areas versus the constant depth in this green will result in a dry spot developing in the high spots. So let's take a look at the data we got from the field, and we'll use a couple of examples to give you an idea of why that the extra depth causes increased suction and results in a dry spot. And the solutions are going to be fairly difficult in this particular case, and it will require basically hand watering. There's no way that you can use your irrigation system to fix a problem of construction like this other than just coming in and adding additional water periodically to those areas. Ideally, if you had a uniform root zone, you'd be able to irrigate once, let the green dry out for several days. It will dry down uniformly, so all of the areas will have the same amount of moisture. In the case of an improperly designed green or a constructed green, if you tried to irrigate once and then let the whole green dry down so you have fast and firm conditions, you'll encounter a problem where the green is deeper. That area will have to be hand watered periodically. To evaluate the depth of the soil profile, we used a simple soil probe to push down through the soil to hit the gravel layer and to measure the depth from the surface to the gravel layer. To measure soil moisture, we used a Spectrum Technologies TDR 300 soil moisture meter. In this graph, we illustrate the change in volumetric water content over the distance of a few feet. The green was irrigated for 20 minutes the prior night so that the surface should be near filled capacity. Note that at 15 inches, the volumetric water content is 27.9%. However, when we sample the depth and moisture moving from the good performing area to the area where the stress is evident, the depth of the root zone increases from 15 inches to 18 inches and the volumetric water content drops to 17.4%. Based on previous research and work that we've conducted and others have also conducted, the target soil moisture for good greens performance and firmness is between 15 and 25% soil moisture for a sand-based green. The 17.4% soil moisture following a heavy irrigation is not a problem, but what if you want to keep the green surface dry and fast? Attempts to dry out the entire surface will result in drought stress where the root zone is too deep. For example, if we drop the bulk of the green area down to 15% soil moisture, a 13% reduction in volumetric water content, the same 13% drop in soil moisture will result in the deep area falling to 4% soil moisture. The deep soil root zone areas will require hand watering. I want to give you a simple demonstration of how water moves to drain depending on the depth of the soil. And to illustrate that for you, I want to use a demonstration that's used commonly in introductory soils classes, and it entails using a sponge. And let me just show you how that works out. All you need for this demonstration is an ordinary sponge, and what we'll do is completely saturate the sponge with water first. Once the sponge is saturated, you can pick it up and you can see water will drain from the sponge a certain amount until it becomes in equilibrium with the capillary suction of that sponge for that depth of sponge, or the amount of water that is the weight of the water pulling against those capillaries is not sufficient to drain the sponge any further. Now if you turn the sponge 90 degrees, you can see that you get enhanced drainage because now there's more water and the weight of water is heavier. It will pull moisture out of the sponge from the surface to equilibrium with the capillaries inside the sponge. And then you can even drain this sponge further by turning it vertically. So the depth to drainage now is all the way from the top down, and you can see that you can pull much more water out of the entire profile as the sponge drains due to the weight of the water in the sponge. So the deeper the sole profile, the more water and the heavier weight of water, the higher suction it will pull to be able to move that water out of the soil. It's exactly what's happening in these root zones that don't have an even profile. It's much drier at the top in the deeper areas, and then it'll be less dry at a shallower depth. We just wanted to put up one additional piece of information. If you want to know the characteristics or moisture retention of your particular soil, you can send that soil into an analytical laboratory, preferably has A2LA certification if you're working with greens, and they will evaluate the soil at different depths. Here we have it at 10, 20, 30, and 40 centimeters of depth, which is equivalent to 4, 8, 12, and 16 inches, and they'll tell you what the moisture content, percent moisture content is for those different depths. So it's a good way to find out how your soil performs, and if you're going to build a new area or a new green or even cap a fairway, this information will guide you on how deep that soil would need to be to result in 12 to 25% soil moisture at field capacity.